This is just a product sum binomial factoring, so we're looking for a product of 6, sum and difference of 5. Anyone have an offer? There's the first offer I heard. Confirm? The problem was you multiply your minus 6 and your positive 1. What are you going to get as the last term? So that's the tricky with a 5 and 6. It always looks like 2, but it matters the sign of the last term. Okay, how do we solve? We split and solve. Hello, Mr. Squiggles. X equals. Well, we're going to check actually using quad formula. So I'm going to show you how to do this with quad formula exactly the way, and it'll come out to be exactly the way we did here. You'll just see why we like factoring, because it's a lot less work. So quad formula talks about this A, B, C. And those are just the coefficients in order. So A is always the coefficient of the x squared, which in this case is 1. B is the coefficient of x, which in this case is negative 5. And C is the constant, which is 6. Formula is x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. Yep, you're always one step ahead of me. So this one I'm going to do step by step, and then I'll show you in the next example how we can skip steps. I'm going to keep the negative that's in the formula. I'm going to put in negative 5 for b. Keeping the plus or minus, keeping the big square root. I'm going to bracket the negative 5 squared when I sub it in there. Keeping the negative 4. Putting 1 in for A, 6 in for C. And then dividing the whole thing by 2 times 1. What I do in the next step is I combine the two negatives. I'm going to evaluate the squared. I'm going to multiply the 4 times the 6 times the 1, and I'm going to multiply the 2 and the 1. Okay, so those 4 kind of pieces that you see. So minus 5 plus 5. Negative 5 squared, and it's important I bracketed that negative because it's negative 5 times negative 5, which is. Then I'm going to do the 4 times 1 times 6, so 4 times 1, 4 times 6. So minus 24. And on the bottom, 2. Now I'm just going to simplify under that radical because we know there's assumed brackets. So BEDMAS says I go to the brackets first. So this is 5 plus or minus the square root of 1 divided by 2. Now, if I can, I evaluate the radical. So if it's a perfect square, we do. If it's don't, we just leave it. So this is 5 plus or minus 1 divided by 2. And then all I'm going to do is split this just like we did yesterday. I'm going to say the first one is 5 plus 1 divided by 2. And the second root is 5 minus 1 divided by 2. So I'm just splitting that plus and minus into 2 separate answers. It's easier to get the 2 answers here, but it depends on your brain. Now I'm just going to evaluate. What's 5 plus 1? Divide by 2. What's 5 minus 1? Divide by 2. So x equals 2 and 3. It depends. If the question specifically states a method, solve by factoring, solve by completing the square, then you have to do what it asks. If it just says solve, it's completely up to you. Some people love quad formula because there's very little thinking involved. Some people love factoring. Once you get used to factoring, this seems like a lot of work, so it really is up to your brain. It's interesting because we always have Brazilian students, and they don't learn factoring at all. They do everything with quad formula. And their thinking is, well, if this works all the time, why would you go to factoring? Because factoring, the problem is you're going to have questions that are impossible. And so you can't factor, so then you have to go to quad formula. They're like, then why not just use this all the time? So they can do quad formula in about 1 step. They just look at it, bam, they know what it's equal to. Because they've practiced and practiced and practiced. Let's look at number 12. Here's one that you cannot factor. How do I know I can't factor this? Well, we can factor without a coefficient of 1. We've practiced those, and that's on our flow chart. That's where we start with the product, so we do the first times the last. So A times C in this case would be 2. What's the sum we'd be looking for? So product is the first times the last, sum is the middle. Okay, so factors of 2 that add or subtract to give us 10. It's only 2 of them, 2 and 1. Is there any way I can combine 2 and 1 and get 10? So here's one you can't factor. It's impossible. You cannot use that method. Okay? So this would be a quad formula question. You don't need to write down the ABC. It's just a left brain thing. We like things off to the side, and we like them categorized. In this case, A is 2, and B is -10, and C is 1. X equals -b plus or minus the square root of b squared minus 4ac divided by 2a. Again, I'm going to do this one step by step, and I'll show you in a bit what you can simplify in your head. So -10 plus or minus bracket -10 squared, -4 times 2 times 1, and on the bottom 2 times 2. So again, I tend to do the negatives, I do the squaring, I do this 4ac, and I do the 2a all in the same step. You could do 4 different steps. -10. -10 squared, 100. 4 times 2 times 1 is 8. And on the bottom, 2. 4. Then I do under the root. Offer of 92. Confirm. Unit 2, Unit 2, Unit 2, Unit 2, Unit 2, Unit 2. I don't know, you tell me. Can we simplify? Yeah, what did we learn in Unit 2 about radicals? We're looking for perfect squares hidden in that number. 4, is that the largest one? You think so or you know so? Everyone should know the answer to this one. So if you're not sure, you can always prime factor, right, to figure out what the largest prime is. Can we divide 92 by 16? Okay, so 4 is the largest. It's 4 times what now? Now, without doing any calculations, you should have known that 4 was the largest. Why? What do you know about 23? It's prime number, so there's nothing else we can divide into this. Oh, well, let's list them out. Woo! Let's list out all the prime numbers up till, I don't know. Well, there's a bajillion million, but let's do the most common. What's the very first prime number? 1 is not a prime. It's not prime. It's not composite. It's either a special. Very first prime number is 2, which is the only even prime number.
1 at special occasions.
No, 1 is always special.
It's special. It's special.
1 is always special.
Yeah. So the first prime number is 2, which is even. You might want to jot these down somewhere. 2. Then 3, 5, 7, 11, 13, 17, 19. Oh, there's a little bit of variation there. 23. 29 is the next one. 31.
So 13, 17,
37. Let's back up. 13, 17. Tell her the next one. No. Okay. 13, 17, 19, good. 23, 29, 31, 37, 41, 43.
No, 47.
Fight it out. 47 is prime, and is there one more before 50? Nope, that was it. That's them all up to 50. So in my house, we celebrate prime birthdays with extra cupcakes. So when you reach a prime, we're like, yay! I have a wild scope before I hit another prime. Okay, so back to what we're doing here. What's the point of this? What do we do with the 4? Ooh, 23. And then last unit we talked, if all 3 of these number have a common factor, we have to reduce. Can we divide 10 and 2 and 4 by the same number? Okay, so 10 divided by 2. 2 root 23 divided by 2. And 4 divided by 2? 2. You have a choice. You can leave it like that, just like yesterday, or you can split it off into the 2 answers. It's completely up to you. So you could write 5 plus root 23 divided by 2 and 5 minus root 23 divided by 2. Or we can leave it. Totally up to you. We're going to do our musical interlude. Okay, let's go on to the next example. No, that was supposed to make you all like rejuvenated and. Music makes you tired. That's interesting. Does it matter what kind of music?
No.
What if it's like super happy dance music?
I can fall asleep to dance stuff.
Notes. What am I about to write a note about? Yeah, something important. Good. Let's talk specifically. What do you think here? Yes, all terms must be on one side. Ooh. Oh. Oh, no. And I hate necks. What are we going to do with the minus 5x? What are we going to do with 7? A and B and C. A is B, C, write down the formula. See if you can do without looking. Like not looking at writing it down, but looking at the formula. Okay, let me show you on this one how I cut steps when I do it. So if B had a negative, I would do the negative now. It doesn't have one, so it's just going to become negative 5. Then I do the 5 squared right away, which is 25. Then I leave the minus 4, but I multiply the A and C, and I don't know why my brain wants to do the A and C and not the 4. It's just the way it works. So I do 2 times negative 7 is negative 14. Maybe because they're over here, I can see it. I don't know. And then on the bottom, I jump right to the 2 times 2, which would be 4. If you want to do less steps or more steps, that's fine. Just trying to help save you some paper here if you want. Because I've done it that way, this is the only thing now I need to simplify. Is just that back piece, the negative 4 times 14. No calculator, do 10 and do 4. So what's 10 times 4?
It's 56, right?
You just like totally stole my thunder on that one. You just like stole that away from me. I'm going to cry now. What's 10 times 4? 40, and then 4 times 4. And then take 40 and 16 and put them back together. Sander, it is? Then I'm just simplifying under the root. $71 with a question mark?
25 plus what? What's that number?
56. 56.
Oh, 56.
Maybe 80 something. 81.
Oh, square root of 81. And then this one I'm going to split because they're both numbers, and instead of radicals, we can just split them. So minus 4 plus 9. 9 is 5 plus 9. Divide by 4. Minus 5 minus 9. 14. Negative 14 divided by 4. But can we reduce it?
7, 2.
So negative 7 half. Okay, and if you need the steps, just put the step in above. So it was negative 5 plus 9 divided by 4, and negative 5, negative 9 divided by 4. Those are intercepts. What else are they? Zeros, roots, or solutions, sometimes we'll call them. Look at 14. The word problem. Read to read. So you probably caught surface area, you probably caught cylinder, and then you got bored. So now let's read to understand.
Surface area. 250.
Kate?
7 centimeters is the height. And what radius?
If I've got cylinder done once, I might not do it again, but you could certainly highlight it again. So you may have flashbacks to the first unit last semester with geometry. Trigonometry's good, yeah. We're going to do that unit 6. It gets even better this year.
Is it like easy still?
Yeah, oh yeah. But it looks hard, but it's really easy. And you're going to be like, damn, I'm smart. It's one of those units.
I don't remember trig. At least not right away. I might remember it.
So I'm lefty, so I like to kind of just write everything off to the side. If this doesn't do anything for you, then don't. We just like to take stock and write stuff. And if you're ready, you might want a diagram. Does it? No. We need the formula. What just happened there? Surface area of a cylinder. How good are your brains? Do you remember from January? Surface area of a cylinder. Something with pi r squared. Why is it 2 pi r squared? Where are the 2 circles? So we assume it's what's called a closed cylinder, so it's not open like a soup can. It's got a lid. In my head I was picturing I opened the soup can, but you're right. If I have not opened it, it is definitely closed. In my head, I'd already opened it. It's tomato soup, by the way, in my head. That should not be an equals plus. But sometimes there's mystery chicken that you're like, that was crunchy. I don't know. Yeah.
That's what I used to.
Never have I ever had that happen. Or when the parent would soup
Kate?
plus H
Almost.
plus
So it's the middle part we haven't done the surface area of. So the height, and what's the other dimension? If I unwrap that middle, it's a rectangle, right? So a cylinder becomes a rectangle when you unwrap it. Here for tactile and visual people. So this part would have been the what of the circumference, right? Becomes this dimension, and what's the formula for circumference?
Or no, wait, circumference.
2 pi r, no squared. So we call it 2 pi rh. So we have surface area, so 250. 2 is a number, pi is a number. I don't have radius, I can't do much there. 2 is a number, pi is a number. Still don't have radius. Ooh, but I have the height, so that's exciting.
Wait, yeah, we have radius.
I have radius.
No radius.
Isn't that a 2 right there?
That's a question mark.
No, on the thing. On the diagram.
That's an R.
Oh.
It's a little tiny r. Okay, well, what do you want to do? Well, what kind of equation is this? Yes, you do. It has an r squared. What kind of equation is this? Quadratic. So if your head has trouble seeing that, what you can do is just replace the r's for x's. So that's not mandatory, but if you want to, sometimes we're so used to seeing x, we like to see x. So you've got an option here. You can say let r equal x, and I can make this 250, 2 pi x squared plus 2 pi x 7. Then let's just ignore that I did that then. What I'm going to do first is just simplify this term, because I got a 2, I got that 7 hanging around, so I'm going to put them together, which would give me 14 pi r. And I'm going to bring that 250 over at the same step, because we know we need it all equal to one side. We check the coefficient of, used to be x squared, this has r squared, and what do we want it to be? Oh no, we're doing quadratic formula. Never mind, I thought we were factoring. Quad formula. A. 2 pi. Remember, pi is just a number, so that 2 and that pi are stuck together. B, 14 pi. And C, negative 250. Okay, so even though there's pi, so what? We're okay with that. Pi's a number. Try to write down the formula without looking back at it. Yeah. Nice, high five.
So I guess we need a cup.
But wait, I'm going to show you it in a second. Wait. Okay, so negative b is going to be negative 14 pi. I'm going to let the calculator do the squaring, so I'm just going to put my 14 pi in brackets and put a squared. And then minus, and I'm like, yeah, I don't want to do all this. Calculator can do it. On the bottom, I might do it because it's easy. So 2 times 2 pi is 4 pi. So when you're putting quad formula into your calc, you just have to be aware of a couple extra brackets. You've got to bracket the whole top, bracket the whole bottom if you don't have the new operating system. If it already does a little pretty fraction for you, you don't have to do that. It will open a bracket under the square root, so you're going to have to close one off. And again, that's if you don't have the new operating system, because it's all pretty and stuff and everything. If you've got the new operating system, you're typing pretty much exactly what you see. Well, I was about to say, but then you all just jumped all over me. We can't do the plus and minus, so we're going to just do the plus for now. Yes, Natasha?
It looks like you have 4 pi there, but isn't it 4 2 pi?
Oh, but 2 times 2 is?
Oh.
4, so I just multiplied that right away.
Dividing it by 2, not by
Yeah, just because it's an easy one to multiply. You could leave it as 2 times 2 pi.
Well, no. I just kind of got confused because the last time I just done that one step, that's all.
So we'll just wait for confirmation on that. I'll do it. Okay, we got like 5 different answers.